Hello and welcome. In this video, our goal is to find the current and voltage drop across the 20 ohm resistor using superposition theorem. To use superposition theorem, we consider the effect of each independent voltage or current source on a circuit component when it's acting alone. Then we superpose it with other components effects. Now, the first power source we will be considering will be this 240 volts power source. We will turn off this power source and this power source, and turning off a current source leaves an open circuit. Turning off a voltage source leaves a short circuit. And because of that, the circuit would look something like this, with the voltage and current, other voltage and current sources turned off. We will call the current due to the 240 ohm power source, 240 volts power source I01, and the voltage drop due to the power source V01. Now, what we want to do is we want to find these values. Then what we can do is we can use simply use nodal analysis. If we use nodal analysis, we have two essential nodes. So we pick this one as our reference node and this as our node 1. So we can write a Kcl equation as node 1, and it will look something like this: V1 minus 240 divided by 5, V1 minus 240 divided by 5, okay, plus V1 divided by 20. So V1 divided by 20 plus V1. Oh, this would be V1 divided by V1 minus 240 divided by 5 plus 7. 5 plus 7. V1 divided by 20. V1 divided by 4 plus 1. V1 divided by 4 plus 1 all equals 0. We can then simply multiply through by 60, and multiplying through by 60 would give us that'll be 5 V1 240 plus 5, 240 times 5 minus 1200 plus, we're multiplying through by 63 V1 plus 12 V1 all equals 0. Then we end up with 20 V1 equaling 1200, and then we have the V1 equals 60 volts. 60 volts, am I right? Yeah, 60 volts. And then that means the V01, which is equal to V01, and we expect the current to be 60 divided by 20. So I01 would be 60 divided by 20, which is equal to 3 amperes. Those would be the current and voltages across this 20 ohm resistor due to this 240 volts power source. You can then proceed to this power source, and the circuit due to that power source will look something like this. Let's call the current due to the 80 volt power source I02, and the voltage due to it, we'll call it V02. Then we can find the current using nodal analysis. We can call this our reference node, and we have only one more essential node here, that will be node 1. All we do is we write a Kcl equation there. So let's go at N1. We have V1 divided by 20 plus V1 plus 84. V1 plus 84 divided by 5. v1 plus 84 all divided by 5. Then plus v1 divided by 12. v1 divided by 12 all equals 0. We can simply multiply through by I think 60 should do it. Multiply through by 60, 3 v1, okay, plus 12 v1 plus 1002 008 plus 5 v1 all equals 0. When I add that together, we have 8, that we are 20. Yeah. 3 plus 5, 8, yeah, 20 v1. Okay, all equals minus volts. So we expect the value of v1 to be v1 equals minus 50.4 volts. Okay, and with that we know that it is equals to v02, and I02 would be equals to minus 50.04 divided by 20 ohms, and that would be equals to 2.52 minus 2.52 amperes in this direction. So the next thing I want to do is we want to consider for the third source, and due to the third source, the circuit will look something like this. And let's call the current due to this power source I03, and the voltage drop due to it would be V02. Okay, then we can use mesh analysis. We can simply use mesh analysis to determine the current and voltage. So we say this is I1, the current here is I2, current here is I3. We already know that I3 is equals to 16 amperes. That's fine. Then we can write a Kcl equation in this mesh, and that would be I1 minus I3 into 7 to I1 minus 16. Okay, plus 5I1. Okay, plus 20 into I1 minus I2, and this all equals 0 as a Kcl equation. And we'd have 7 plus 5, that would be 12, plus 20, 32. Okay, it would have 32 I1, okay, minus 20 I2, minus 20 I2, okay, 7 times 16, that would be 112 equals 112, and we can call that our first equation. We can then proceed to the second mesh. If we write the equation in the second mesh, we have 1I3, I2 minus I3, so we have I2 minus 16. So we have I2 minus 16, and we have plus 20 into I2 minus I1, okay, then plus 4I2 all equals 0. Then we would have 1 plus 20 plus 4, and that would be 25 I2, okay, and we have minus 20, so minus 20 I1, okay, all equals 16. Okay, then we have two equations which we can solve simultaneously. And from there, we find out that I1 would be equals to 7.8 amperes, and I2 would be equals to 6.88 amperes. Okay, and we expect I03 to be I1 minus I2, so that would be 7.8 minus 6.88, and I03 would be equals to 0.92 amperes, and we expect V02 to be equals to 0.92 times 20. So when we multiply that by 20, we get 18.4. So V03 to be equals to 18.4 volts. Now that we have these three values, we can then add them together, and that will give the total effect of all the current and voltage sources in the circuit. So we know that I naught is equals to I01 plus I02 plus I03. Okay, and that would be equals to first we have current 3 amperes, then we have current minus 2.52 minus 2.52, then we have current plus 0.92 plus 0.92, and all of this equals 1.4 amperes. And then the voltage, we have V naught will be equals to 60. V naught equals 60 plus minus 50.4, okay, plus 18.4 plus 18.4. V naught would be equals to 28 volts, and that will be all for today. Thank you for watching. Bye.